Welcome to Old Iron Machine Works. It's been a little while since I put a video out. Got a lot of content, just haven't found the time to edit and put a video together. But I want to thank my new subscribers. This video is gonna be about this cart, a little hydraulic lift cart, and it'll have some working on a large gearbox at work. It'll be kind of like a little combination video. This cart I think is one of the handiest carts any shop could have. We picked this one up years ago at an auction not too far from where I work, and then later on I picked one up on Craigslist. Actually, I found it on Craigslist and I picked one up for home. A while back I did a video, one of my first videos showing my cart at home, which is this one, where I built a frame that holds the chucks for my big lathe, and I use this cart for putting the chuck on and off of the lathe. This chuck's about 210 pounds. I'll have a video coming up, hopefully not too far down the road. I'm restoring a 18-inch 6-jaw scroll chuck for this lathe, and it'll weigh in at over 300 pounds. So the system I use for putting the chuck on should work real handy. Now these particular carts, this one and the one I use at work, they have a 880 pound rating, lifting capacity. Alright, you just slide it right in there, put it over the carriage, and let it down. I made the saddle fully adjustable in and out and up and down, so you could pretty much have it lined up perfect. Okay, at this point now, we just line up the key here to where it starts. And that just pulls out. These come back off. Saddle comes off. We've now moved over to some large gearboxes that I rebuilt at work. I do quite a few of them actually. Here I got the quarter power set up, and I'm pulling one of the old bearings and the wear sleeve for the old style seals. I will show later in the video exactly I'll incorporate the cart into working on the gearbox. I just kind of thought I'd make a combination video showing the cart and actually showing one of the many projects that I do at work. What we got here, these are the gears and shafts. We've had problems where they didn't have a tight enough tolerance, and we had some that the bearings would spin. Metal spray was not an option. Welding shafts up for the customer was also not an option. So I got a hold of Chrome Craft up out of Sacramento that I used to use years ago, back in the late 70s. They did a lot of crankshaft work for, hot rods and whatever. And now they're more industrial stuff. This is industrial hard chrome. Industrial hard chrome comes in at about 61 Rockwell, so you're not going to machine it. They undercut everything, put it in the tanks. They tape the gears and everything up that they don't want plated. Put them in the tanks, build up the hard chrome and grind them to size. And I give them exact size plus half thousandths, and they hit it every time. Here I'm heating the bearings up. Normally I'll go 160, 170, and I've never had a problem putting a bearing on. Normally they just slide right on. I don't like to overheat a bearing at all. And and so far they've actually worked perfect, but I actually had one that didn't go all the way on, which you'll see here in a minute. Normally when you're putting the bearing on, it's nice to have a block of wood and a hammer, just in case, because when you're getting them started, you know, they kind of cock around a little bit, and generally once I get the bearing on, I generally like to try to rotate it until it finally starts seizing to the shaft. Once the heat starts transferring to the shaft, the bearing's shrinking, the shaft's growing, you know, pretty much it's on. If you're not familiar with an induction bearing heater, you are looking at one right now. For these bearings, I had to get some extensions, which was in the blue, to raise them up high enough for these big bearings. I'm not going to say I've never heated a bearing up with a torch. I've been doing this a long time, but you should never heat a bearing with an open flame. Where the induction bearing heaters are awesome. But see that gap right there? This bearing did not go all the way on. I kind of got in a hurry. I didn't get it quite hot enough. I thought it was going to be okay. It wasn't. And this is where the cart comes in. I do not have good access to my press, and I need to press that bearing the rest of the way on. Out of the 4 bearings, that's the only end that does not have a threaded hole where I could get through it with the porter power and just finish sucking it all the way on. And this is where the cart came in real handy. The shaft and gear weighs 800 pounds, so clearly it's under, if I don't lean on it too hard, it's under their max load, and it allowed me to wheel it over and get it to the press. Here it's just showing the weight of the 800 pounds, the weight of the shaft and gear. I've been working here 21 years now, and when I first started there, they just had a little upside down bottle jack press, 20 ton. So I found this 60 ton Manly 1952 on Craigslist and told my boss, you know, we need to buy this. Kind of always wished I would have just bought it and took it home, but I do. It's almost a daily user at work. Okay, I needed a piece of material that would be about a couple inches thick, but that would go from the press, the bars on the press, to the bearing surface for me to press against. So when I'm pressing the bearing on, I got full contact around the bearing. And I could not find anything around the yard, but I did have an old bearing, you know, off of one of the deals. And I thought, okay, I'll make it work. It'll work okay. You know, but clearly bearings, they're very, very hard, so I needed to soften it up a little bit. And the best way to soften it up a little bit is get the rosebud out and heat her up. Even though I softened the bearing up where I could machine it, I wasn't going to run a nice edge. So I just took one of the ones that was chipped and took it to the diamond wheel. Kind of put an edge on it that will remove some material. I run the T&MG 432s. Those are just some I think I got on sale a while back at a MSC. On the bearing that did not go on all the way, I do not have the shaft sticking out to pilot off of. So I'm machining the outside edge of the old bearing that'll fit right inside the cage that holds the rollers in place, and that'll help center everything. Because with the shaft sitting in the press, kind of blindly there, I'm going to have to raise the shaft up slightly with the lift cart and then slide this bushing up underneath, so it'll fit right inside the cage of the rollers and help align everything. Okay, that outside edge right there will fit right inside the cage. to help center everything. That edge right there will be the part that pushes up against the bearing. Here what I'm going to do is go ahead and relieve a little bit of the inside to where if I ever do have one doesn't go all the way on, rather than trying to fight the fact that it's a press fit on the shaft, I'm just going to go ahead and relieve the material right now, and it'll just be another tool that I add to my Gearbox toolbox. Okay, there may be somebody out there that is questioning, why aren't you flipping the jaws around and grabbing the bearing on the outside? And it's real simple. I'm just doing a relief cut, just so it doesn't, it's not tight on the shaft. And it's a lot faster for me to take the bearing out, flip it over, make another cut, and be done than spinning the jaws around. Now here, once I flip the bearing over, before I flip it over, I just take a marker and just grab a line. Just mark a line with a marker. I don't really care what the numbers are. All I'm going to do is machine it back down to where my black marker lines line up, and for what I'm doing here, that's good enough. I think I've had 27 bearings go on without an issue. So the reason I machine the inside of the bearing is if I ever have a tight one, I can slide that on there. Now the outside of the old bearing fits right inside that cage. That's going to help me center it up when I go to slide it in the press. And when I go to slide it in the press, the bottom side will just sit against the bars on the press. And then the lip, put it up there, Gary, there you go. And then that lip will just sit right inside that cage. Here, I guess I need to apologize. I did not get the actual footage of pressing the bearing on. It did take 5 ton, which is nothing. 5 ton on a 60 ton press. I just slid the coupler up underneath, or the bushing, and set it on there and just pressed it down. It worked great. And now just bringing it back off of the press and taking it back over and getting it flipped back over. Here's another little apparatus I built years ago just for holding the shafts and gears. I had 3 carts that weighed 1,000 pounds each. Not 1,000 pound capacity, but they weighed 1,000 pounds each. That I actually sold to my boss just for working on gearboxes. And I made one of them strictly just for holding the gears, so I can pull the bearings on and off and whatever shaft work I got to do on them. Here I'm just getting the shaft back into the horizontal position where I can set it back on the cart. I did already mention it, but the bottom shaft, which that's the bottom shaft, weighs in at 800 pounds, and the top shaft weighs in at 600 pounds. Here I know the shaft weighs 800 pounds, so I will put an 800 pound strain on it to kind of balance everything out, and it makes it so much nicer for prying back and forth and checking my backlash. as it moves back and forth, it's nothing but a big old teeter-totter, when you have the capable bearing. I've tried lots of different ways, and this by far has worked the best for me. Here I'm machining the area that goes up against the cup of the bearing. There's no shims or anything involved in these. You have to machine depending on your clearances. You either have to machine that area right there, or you got to machine the area that bolts right to the housing. If you want more clearance, you take it off there. Less clearance, you take it off on the area with the bolt holes. Now these covers require quite a bit more machining because I'm putting a new style Labyrinth style seal on them and getting away from the lip seal. So when I'm checking my clearances, I'll start out with pretty thick shims, and then I'll do an initial cut that could be as much as 80 thousandths on the first cut. And then here I've already made my first cut, and I put my 5,000 shim in, and I don't remember exactly what cut I was going to make on this one, but I'm thinking it was going to be like 3 thousandths or so. But here, just kind of squaring up in the 4-jaw chuck, all you can really do is zero each point of contact with the chucks, and that's as good as you're going to get. If you see any kind of run out, that's just slightly distortion in the cover. Okay, so here it looks like I'm taking just about 5.5 thousandths off of this. So this should be the final cleanup pass, and this is for the bottom shaft. The run out back and forth that you see, the wobbling, that doesn't mean anything because the lip that I'm machining, as long as everything's dial indicated, you can see the big 4 slots. It's got a relief cut anyway, or should I say an interference cut. So and then here I'm just running around with the little Scotch-Brite deal. Most of the time when you machine any kind of cast, it leaves little fuzzy, areas. So just kind of smoothing it out a little bit. Okay, here I'm just kind of verifying. Yeah, okay, I got my 800 pounds. So kind of equalizing the weight of the shaft and gear and everything. And nothing fancy here, just a hard 2x4 that I can get down in there and put a load on. It's hard to imagine that, flex the housing that big, but you actually can if you really bear down on it. But what I'm going to be looking at is I'm shooting for my 2000s in play. So here, just move the board over and push on it, pretty hard. I mean, I push on it as about the best I can do, and there's my 2000s. So that one's ready to go. Alright, here we're off to the top shaft. The top shaft weighs, I said 600 earlier, but 650 it's what they come in at. And here I'm just getting the shaft and gear assembly set in there, and then the next top cover will go on it. Now, as I mentioned earlier, this gearbox had the old style lip seal. It's just a typical rubber seal and the wear sleeve. Unfortunately, when those would crack and go out, it's a huge job pulling all the couplers off and heating and pulling the hub off to change. With the new Labyrinth style seals, there's absolutely no wearing parts, so they pretty much, no service required at all on the new style seals. Alright, here we have the new style Labyrinth style seal assembly. The threads right there just kind of push oil to the inside. This slip here, any oil that makes it to that tip naturally wants to sling it off of it. Once it slings it off of it, it slings it into this cavity right there. And then the oil from there just kind of drains down, drains down around and then drains right back into the reservoir. Now that the inside sleeve that presses on has an O-ring that seals. This is also an area that everything drains to the bottom, as far as the oil getting slung off. That part fits up against the bearing cup. This part of the sleeve has a O-ring that seals to the shaft, so you don't get leakage between that sleeve and the shaft. Here we have another installer sleeve that I made. As it presses on, this prevents the O-ring from wanting to roll or shear off a little part of the rubber. And this part is like the last line of defense. This is made out of aluminum and it's got really tight tolerance. When it's all installed, it's got about a 3/1000 gap, to where any oil that's wanting to get past that gap is going to drain off and then drain down to a drain hole and once again back into the sump. Here I'm just assembling the 3 main pieces of the seal assembly, and then it'll be pressed on as one unit with a big porta power. That roll pin I was just pointing fits in that hole, and that keeps that part from ever wanting to spin, and that's going to be up against the bearing cup. Now in the past I had some situations where they did not drill one of the holes deep enough for the roll pin to go into. And what would happen is the roll pin would bottom out, which isn't good, so you either grind the roll pin or drill a hole deeper, one or the other. So what I do here is I just take some of my favorite shim stock. This runs between 0.5 and 0.7 of a thousandths. I don't know if this was a particular Disney movie or not, but just a VHS cassette. Everybody's got it. And what I'm doing here is just kind of clamping it down, just putting a little pressure on it, tap it down, and just make sure that it pinches that, that material. It's not good, to have it bottom out against a roll pin. So it's just a quick little simple test. Make sure there's no problem. Probably should show more of the card again. So here I'm just going over to get the porta power. Unlike a pallet jack will move stuff, but it won't stack stuff. Nice thing about these cards is you can actually raise them up and stack stuff if you don't have the platform on it, or it's got a little platform, table that covers everything up. Here I'm getting ready to press the whole seal assembly on. Right in here will be the area where the O-ring will seal up. and that's just more tooling that I made where quarter power will suck it on. You know, here you see initially, you know, I'm squeezing everything on. Now at this point I'll have to goop it up, you know, put the sealer on it. I use a Hylamar sealer, and you know, I kind of put it on and let the Hylamar just kind of flash and set just for a little bit, and then go ahead and press everything on. I guess I should mention there's only 2 gaskets on this entire gearbox, and it's just some little inspection holes on both sides of it that you can pull off and inspect or put oil in it, or everything else is just glued with the Hylamar. Alright, what we have here is I took one of the old seal housings that held the lip seal, and I just rolled a piece of square material that I set in up against the bearing cup, and then I'll take the other main old housing that held the seal, go ahead and stick it in the hole where it goes up against the you know, that ring that I rolled, and then I'll just go around with some bolts and then just kind of start snugging them up and just make sure that everything's seated properly. You know, generally the bearings are already seated pretty good, but just to make sure. Okay, what I'm doing here is just machining a 1 5/8" 12 thread hole in the end cover for the top shaft. Here is one of my interesting one of my threading tools I made a long time ago. It's actually threaded a bunch of holes already. Maybe not some of my prettiest work, but it works great. I'm running it, I'm spinning it reverse to where when I'm threading it's pulling out of the hole. I'm eliminating any kind of pucker moment of crashing anything. Don't worry about crashing anything when threading that way. Here I'm just putting a little radius on for the O-ring to actually seal against, and the threads just pull the plug in and the O-ring does all the sealing. And this hole is actually for me to raise up the shaft to kind of support the shaft while I'm setting the clearance. And you'll see later in the video it'll make better sense. Alright, here's my setup. I just got a block bolted in where the keyway normally would bolt in, just to give me a pry point where I can pull the shaft one way, you know, up tight, where the rollers are up tight against the cup. And then the other side here, same thing. That's an old Kubota top link that I did some modifying to that fit the shaft perfect. It's all metric, and that way it allows me to pull the shaft, you know, in that direction. And then here's some 100,000 shims. I'll start by putting 100,000 shim in, and then decide how much I got to machine off. Here I got some magnets. I don't have enough hands to hold the shims from falling out, so I just put little magnets there to keep them in place. And here I'm doing the same thing I did with the bottom shaft. Basically the wood just keeps the strap spread out where it doesn't contact the sides of the case. I'm trying to do with one hand to get my 600 pounds, but basically it's between 6 and 650, and that's what I put on this scale, you know, before I start adjusting. Here I'm just taking my old DeWalt, and the initial first cutting I just zap them down with the small little gun. You know, and it's fine because normally it's a pretty heavy cut. You know, with 100,000 shim in it, you can see here I think it was 18 thousandths. You know, and then just do the math, figure out how much I want to take off. Okay, ready to check some clearances here. I have the 100,000 shims on the other side. I got 18 thousandths backlash right now. So I decided to do an 80 thousandths cut for the first cut. Okay, now I'm work my way over to the 5,000 shim. I got a 5,000 shim every bolt, which is 8 of them. and I got them zapped down tight with my 1/2-inch air gun. And then I come over and I check my my play. Okay, with the 5,000 shim in it, here I'm prying over, I got 4,000s. So what I decided to do, I decided to take 3,000s off, and that should put me at my 2,000s clearance. Okay, once again, the oscillating in and out means absolutely nothing. The only time that would cause a problem is if you were spinning it fast enough where you had a balance issue, where it started wobbling because of balance. Unfortunately, I put the cover back on. I was shooting for 2,000s, and I had almost 3,000s. So now I had to go back in and dial indicate to run out in and out perfect, because it's got that lip, and then go ahead and true up, the mating surface where it bolts to the housing. And all I had to do is just make a 1,000 skim cut there. Here I always keep the indicator on there, doing a 1,000 skim cut, and I just keep the indicator there just so I can always watch it, make sure there's no movement with the carriage. And then once again, I just take the little Scotch-Brite and just kind of run it around and knock some of the fuzz from the cast off. And here I'm looking for my final 2,000s in play. So I'll put pressure on, pull in the shaft one way and zero it. And then come over on the other side and put a fair amount of pressure where it's pulling the rollers up into the cup. And there we go. Got my 2,000s. And we'll generally add the Hylamar. I generally find where it adds, around 1,000s actually. By the time it's, squished out, it will gain about 1,000 thickness. Now here, these hubs do have an interference fit, so you have to heat them up to go on and off. Of course, going on is always easier because you don't have to worry about heating the shaft up. Here I have a little gauge that I bolt to it, to where once you slide it on, this one here you can slide on too far, and you got to have it set at the right depth. Otherwise, when they go to align everything, if they have to heat and move the hub, that's not a good thing. So that little bar, I just slide it all the way into where it's up against it and let her cool down. Here we got some grabber green from Duplicolor. It's a ceramic paint, and if you've ever watched Ray at Ray's Garage channel, you've seen him redo a Wilton Vice not too long ago that he was using the exact same paint. When I seen that, I kind of got a chuckle because I go through a lot of this paint on the gearboxes. That one is ready to go out. This one has 30,000 hours on it. This has the old style lip seals. The new style style seals are pretty amazing. You won't get any of this slobbering, although that's not real bad for the amount of time, but you won't get any of that with the new style Labyrinth style seals. I guess since we're at the end of the video, I should say what the gearboxes are for. That they run generators. They go between big engines and a generator, and they're used at landfill. And what they do is speed up. They take an engine running at 1500 RPM and speed it up to 1800. This is one of the engines that we were involved in swapping out, and that basically powers through that gearbox into a generator, and it basically burns the landfill gas, you know, that's coming from the garbage. I want to definitely thank all my new subscribers to the channel, and of course, you know, my subscribers that's been with me from day one. Very much appreciated. If you like this kind of content, I think it's hard sometimes to try to come up with stuff that you think other people may find interesting. If you find this kind of stuff interesting, give a thumbs up. If you're not a subscriber and you like it, that's always great. You know, subscribe to the channel, hit the bell, and hopefully we'll get a little more videos out here sooner than I have been.